Hello everyone, today let's go over an easy question. I believe this is part of the Grind 75 list, but I'm not sure. Either way, this is a very fundamental question, and it's good to learn depth first search of a binary tree, the basics of it at least, using this question. So this one's called path sum. It's a pretty early question, and it simply asks you to find the sum of the root to leaf paths, and if they equal target, and if it does, return a boolean to indicate whether you find one or not. So you're given the binary tree. In this format, this looks like an array, but it's not. This is a tree. And simply, you want to start from the top of the tree, try every single path, and if one path sums up to target sum, return true. If not, return false. So if you know how depth first search works, we are going to do exactly that. So when we get to the bottom, let's say 5, 4, 11, 7 is what? 9 plus 11 is going to be 20, plus 7 is 27. 27 is too big. So we're going to pop and then go back and then add 2. And then that's going to be it. So we're going to return true. If that was not the case, we pop, 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 and then append to the end of the stack. So our stack is going to look like 5, 4, 11, 7, 5, 4, 11, and then 5, 4, 11, 2, and then 5, 4, 11, pop 1, pop again, and then add 8. So this is a call stack. It's good to visualize it. 5, 8, 13, pop that. So 5, 8. So every time you pop, just think of it like backtracking by one step. The recursion is going to kill itself and then go on to the next recursive call. So one recursive call is going to end, and then 5, 8, 4, 5, 8, 4, 1, and then we're going to keep popping. We're basically done, right? So I don't want to show you the rest of this. That's pretty straightforward. Just pop, 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 done. If you can visualize this, it helps a lot. So let's code it up. Let's define a recursive function that's going to take the tree node as the input. And we're going to kick off our recursion here. Define our base cases always. If we reach a none node to the far left or the far right, whichever way, then we're going to return none. And that recursion call is going to end. We're going to dig all the way left and then come here. We're going to dig all the way right. And then we're going to say we're none. And then we're going to go back to the previous one. And then we're going to call this again here. And then along the way, we want to define an integer variable because we're going to be returning true or false based on whatever this recursion does when we finish all the paths. So if it's not none, then we can add the value of the node itself. Let's print self.result to C. So 5, 9, 27. As I said, then backtrack. So here, we actually also need to define a case where we're at the leaf node. So if not root.left and not root.right, then we know we're at a leaf node. For example, 7 or 2 is a leaf because there's no left child or it's a none. There's no right child, it's a none. And in that case, self.result equals to 0. And we also want to print self.result. And we also want to return because we're done with that path. Actually, 1 second here. So it's actually a better idea to not use a result variable. Let's use a stack to make it easy to simulate. And we're going to append the value, right? And then now, if not root.left and not root.right, let's print the current to see. So now you sit here, and then we want to pop though because we're done. So cur.pop. Let's see. 5, 4, 11, 7, 5, 4, 11, 7, 2. There we go. So if we reach the leaf node, then we can pop. So it's not here. This is for another purpose. So now if we hit a leaf node, then we can ask the question, right? If the sum of self.current is equal to target sum, return true. And then if we get all the paths 5, 8, 4, 1, and we never return true, then we're just going to return false. This is not right. 5, 4, 11, 7, 5, 4, 11, 2. Okay. Okay. Sum of self.current, 27, 22. Yep. So if this is equal to target sum, it's going to return true. Okay. Let's call this self.flag equals to true. Because this returning true just kills whatever recursive call started this. It doesn't actually return true because we're still inside of the recursion. So we're just going to return self.flag at the end, which is going to be a Boolean. So it started as false, and we're never going to, unless we set it to true. Okay, what's going on here? Okay, I think we might need to add this here instead, because if we're at a leaf node, we don't want to add. Because we want to, when we finish, it's like a depth first search. No, self.cur.pop. Times this can get confusing. And then, so like a leaf, we always want to pop. Yep. Okay. Not sure why this is wrong. Oh, you know why? Because this is where we want to do it, not when we get to the left. When we get the left and the right child, then we can say we finished the full path. Then we can do this here. And then we always pop at the end. I think sum of self.current. Yep, equals target sum. Okay, we don't need this. This is odd. Self.current. Okay. That's so weird. It's either here or here that we added it last. This is really confusing. Let's print self.current again. Okay, why is this not doing this? So -1, 3, yep. None. Okay, why is this supposed to be false? I don't understand. Okay. Yeah, maybe you have to pop both times, whether we're here and or here. So after we finish the recursive calls, then we pop. So this is really confusing. I'm sorry about this. But hopefully this sort of made sense, at least the diagrams, but you just have to sort of play around with the code a little bit to get it to work. And other than that, I think that that's going to be it. So yep, so stay tuned for more. I hope you enjoyed this video, and thank you for watching.